Hello everyone, welcome to the Code Code. And in this part, we are going to climb the first step for our CI/CD pipeline with the understanding and integration of deployment orchestrator like Docker Swarm. So, what are the things which we are going to cover in this part? Let's check it out first. Okay, so first of all, we are going to understand what is the concept of deployment orchestrator, why we need this deployment orchestrator, and how it works. Then why and when to use the Docker Swarm. Okay, there are multiple orchestrator in the market, but when to use the Docker Swarm and when to use the other, that we will also clarify in this part. After it, we are going to install the Docker Swarm, and then we are going to create the Docker Swarm deployment template. So till now we have created the Docker Compose production level file, and from that file we are going to create the Docker Swarm deployment template file, not template file, actual file. We are going to work on the Docker Swarm deployment file. Once it is created, then we are going to deploy the application using the Docker Swarm. And when it is created or deployed, then obviously we are going to test whether our application is working or not. Okay. After the test, we are going to scale the application. We are going to see and we will verify whether the scale thing is work or not. Like why we need the scale, that part we will also cover when we are going to scale the application. So first of all, let's come to the concept of deployment orchestrator. So in the concept of deployment orchestrator, there are to understand this deployment orchestrator, we need to ask few questions, then we will move into this because learning all the theories will not work. We need to understand why these things are required. So first of all, how can I automate the complete deployment? So you have created the application, there are few services, you need to integrate them, and after integrating them, you need to deploy it. So anyhow, there are few commands which you need to run manually. Then only your application will start on the server. But can I automate the complete process? Okay, it's the first thing. Second thing is how to handle application crash automatically. Let's say your application is running with some container on a machine and that container got crashed because of some resource issue or because of some malicious input request. How we are going to handle this kind of situation? Because if there is no one watching that container, then it means for that particular time or for that particular time period, your application will not work for the users, and that is not good. Again, the third question, how to handle increased load on application without manual efforts. So let's say your application is running and there is some time period in a day or in a month when you expect the user will, the users or the load on your application will increase. So in that state, you cannot 24 by 7 monitor your application just to monitor that, okay, I'm getting these many requests. Now I need to upgrade it or scale it. So that thing also should be automated. Now, next thing, how to handle networking between my application components if I need to recreate it. So let's say you are working on some machine and you just deployed your application manually. While integrating the services, you had to provide some kind of domain name system or IPs of those machines where that application is taking request or providing some response to it. So in some scenario, your server got shut down or some crash happened at your server and you need to recreate it. So then again, you had to work on all the networking part. You need to collect the IPs, you need to collect the services. And also if that particular machine is some kind of virtual machine, that then it can change its IP at after some time or after some upgrade or after some maintenance. Then again you have to do these all things to collect the data of all the networking components and then to put it in your application. So these are the questions like how can I automate these all things? How can I scale it? How can I watch it without any manual effort? I want a machine to run, I want a machine to watch over these all parameters, and whenever a machine detect these kind of changes, they will do it from their own. They don't need to ask me every time. Okay, so these are the question which comes which sorry which created the necessary of the deployment orchestrator. So Okay, so this is the deployment orchestrator, which will help to overcome these all kind of scenarios. And what are the deployment orchestrator which are present currently in the market? So first of all, there is a very good Kubernetes. This Kubernetes is really good deployment orchestrator. It have all the things which you can even imagine. Then the Docker Swarm, obviously, we are going to work on it, and we will understand what are the limitation of this Docker Swarm, and but why we are using the Docker Swarm and where to use it. But there are also some other components or some other players too in the market of deployment orchestrator, but underneath they are using the same concept. Like this AWS ECS. This AWS ECS is just an orchestrator to manage the Docker containers inside the AWS platform. Same like this, we have the AWS EKS. It is the uh, platform of provided by the Amazon Web Services to handle the Kubernetes deployment orchestrator. Okay, so and also this Azure is also providing AKS. Again, it is for the Kubernetes, and then it is Google GKE. This Google GKE is also for the Kubernetes. So anyhow, if you see, there is one or two common thing between all the orchestrator, like underneath or below some hood, they all are using either Kubernetes or this container. Even this Kubernetes is also using the Docker container. So this Docker container start from the very basic point, then there are hoods on top of it, then again another hood, which is creating these services. Okay, so these are the deployment orchestrator, mainly famous orchestrator, which are present inside the market, and we are going to work on the Docker Swarm. So, but they all follow one single concept because of their different platform. They are providing some feasibility over one another, but there is a one very basic concept between all of them. Okay, so let's understand the concept, like what is the architecture of it in a very simple way. Okay, so it's a very basic, I'll tell you. Okay, so there is, let's assume uh, it is a simple plain box, and or you can say it is a network. Okay, so let's assume it is a network, or inside this network there are three machines: machine 1, machine 2, machine 3. For now we will assume machine 1 as master and machine 2, machine 3 as worker, but these three machines, they all can be of same type. So when a particular set of machine present inside a network, that particular machine network is called as cluster. In a cluster, there are multiple machines and they all machines are connected to each other. Okay, so it is the cluster. Now, let's say there is a one traffic, the user traffic, which is coming from the outer world to your cluster. This cluster is like a network. You have created the network. Inside this network, there are multiple machines. So first of all, what happened is whenever the traffic comes, this traffic comes to the Nginx. We are taking Nginx here right now, but okay, but it is mainly a ingress controller. It can be Nginx or it can be other servers as well. But right now, for the understanding, we are using Nginx here. So Nginx is a ingress controller. What ingress controller do? Ingress controller read the rules from the machine. Like what are the rules? Okay. So this is the machine one, which is acting as a master. And if I go in a normal ways, what is the master what master do? The master is the one who provide the instructions to everyone. Okay, you have to do this, you have to do that, you have to do that. Okay, so in this way the master work, and the worker is the one who takes the instructions from the master. Okay, so let's understand first of all what where the traffic go and how it works. Okay, so we have the traffic which is coming to the Nginx. This Nginx is taking the rules from the machine 1. And what kind of rules? First of all, this machine 1 is connected to the machine 2 and machine 3. It is connected, and then it is creating the rules like, okay, this machine 2 have this much load, this machine 3 have very less load. Okay, so it will create a rule, and this rule it will send to Nginx, This Nginx will read that rule, and after reading that rule, this Nginx will understand, okay, now the traffic I need to send to machine number 3 because it have less traffic and machine number 2 is already busy. So in this way, this complete networking work inside a cluster with the multiple machines. And let's discuss bit more about this machine one, the master. What it do? First of all, it will check the health of nodes. So in a deployment orchestrator, there is a one master node. The nodes are nothing, just a machines. Okay, so there are the master node and the worker nodes. Worker nodes can be multiple, and also master nodes can also be multiple. But here we have only one. Okay, so here we have the master node. This master node, first of all, it will check which node is healthy, which machine is healthy. It will send some kind of commands to these machines. It will retrieve the data to check whether, okay, these machines are in working condition. So when it get this kind of metrics, then it will send this metrics to the Nginx. Nginx will read, okay, I have these machine number 2, machine number 3. They both are connected to this network and I can send data to either of them. Okay. So first of all, it will check the health of nodes. Then it will check the health of pods and containers. So what are pods? Pods are the uh, entity from the Kubernetes, and underneath the pod there are the containers. So if you go and open the pod, there you will find multiple container, and containers, the slash containers, they are from the Docker. Again, everything start from the Docker itself. So here we have the one machine which is reading, okay, from machine 2 and 3, okay, these nodes are healthy. Then it is checking when the machines are healthy, then what are the condition of these containers which are running inside the machine 2 and machine 3. Let's assume your application is running on machine 2 and machine 3. Just assume your application is running and machine 1 is understanding, okay, these two machines are there which are running the application, which are consuming these many resources. And now I need to figure out that the traffic which is coming from the internet, where I need to send it. So this master node is the one, is the controller who decides like where the traffic should go and how the traffic should be handled. Okay, so first of all, it is checking the health of nodes, then it is checking the health of containers. If any containers goes down, then it's the duty of this master node to create a replica for it, to create another replica. Let's suppose your container goes down because of some XYZ issue, then it's the duty of this machine one to the master node to create another replica of that container so that the traffic can be so the traffic can go and use that container to do the process or some request response. Okay. Another, it decide which node will have the containers. Again, it will check the metrics like where the resource can be create, and it will not affect the performance of the application. So this machine node, this master node will decide this too. Again, it will create rule for the traffic based on the requirements on the runtime. It is a summary of that same thing which we are discussing till now. So this machine one, the master one, is something which is doing all the hard work for us to checking whether the nodes are healthy, checking whether the containers are healthy. Even if I'm going to scale my application, this machine one will decide where the extra container will go and start. Like in which machine the extra container will go and start. Okay, so it is the simple deployment orchestrator architecture. So when you integrate the deployment orchestrator, it will provide you this much of uh, functionalities in your application, and it is required for our deployment pipeline because we are going to deploy our application in a way so that it can take traffic from the actual users. Okay, so it is the basic concept of deployment orchestrator. And then why and when to use the Docker Swarm. So first of all, if you are new to orchestration, so directly jumping to the Kubernetes. See, if Docker is at level 1, then Kubernetes at level 10. So it this much gap is present between the Kubernetes and Docker Swarm. So if you are new to the orchestration concept, if you want to understand where you are like how these all things work, then you can, once you understand this, then you can move to the Kubernetes part. Not only you, actually, I want to work on the Kubernetes part. Uh, like I'm working from like around 5 years on it, and I want to create a series on this Kubernetes. But I want to understand like at which point you guys are standing at right now. Like if you want me to explain it from the beginning, or you have some knowledge, or you want me to explain from some certain point. So that I want input from you in the comment section so that I can design that particular part in a way so that you can use the Kubernetes as well. And when you introduce the Kubernetes, then all the cloud platform will open to you. Okay. So if you are new to the orchestration, then definitely you should use the Docker Swarm. Like second, for the small to medium application, like there are certain application which are enterprise level and which are used like from the worldwide, like worldwide people are using it, and like, there are different metrics to define your application as small, medium, or large. It completely depends on like how much data you are processing from the internet. So if you understand that, okay, I have only few users, hundreds users, thousands users, then Docker Swarm is definitely good. There's no need to go and use the Kubernetes. There's no need to complicate the things. If you can do the things easily, then definitely you should do it. Then simple microservices. Let's say you are hosting a application or API server where you are selling some microservices which are good for the users but will take less load or need less resources, then definitely you should go with the Docker Swarm. If you are using Docker Compose, if you have set up everything inside the Docker Compose, then you should use the Docker Swarm. But it is not the limitation. If you want to use the Kubernetes, it is somehow very similar. But we are not going to use the Docker Compose here. We need we will use the same kind of syntax in the Kubernetes, but that particular file, but that particular deployment file in the Kubernetes will be executed through different command. There we will not use the Docker Compose command, but the syntax will be somehow similar. Okay, so if you are familiar with the Docker Compose, if you are expert, if you are good in the Docker Compose, then grabbing the concept of this Kubernetes will not be difficult. It will be very easy. Okay, cost effective. So if you have application where you do not have very much money to spend, you want your application to be cost effective because Docker Swarm is mostly used on 1 to 2 servers, like in a limited servers it is used, and it might be possible that you are using a very large cluster. It might be possible that you are using a heavy load. It can be deployed, but there are other tools as well which can do the deployment of a large scale cluster very easily in place of Docker Swarm. So if you are working on an application and you want to deploy it in a cost effective way, because it will terminate all the other required service for the large scale and application. So this cost effectiveness is a very plus point for the Docker Swarm. When you want to scale with set parameter, not auto. So there are two things. First of all, the Docker Swarm automatically do not scale your application, but you can scale it with the third party tool like the Prometheus and another tools which monitor your application. So what it do, when you integrate it with the Prometheus or some another monitoring tool, what they will do, they will collect all the resource metrics from your node, and then after collecting those resources, or sorry, data, it will check whether some certain condition passed or not. If some certain condition passed, then it will execute a script, and that script will run the scale command of the Docker Swarm. So in this way, if you have some budget of another monitoring tool, then definitely you can automate it. There is no foundation to it. So you can do it, but with the help of third-party tool. Okay. So till now we have covered the concept of deployment orchestrator, we understood the use of Docker Swarm and when to use it. So now let's go to the part where, okay, where it is. Okay, so let's go to the part, what happened? Okay, so let's go to the part where we are going to install the Docker Swarm. So, okay, let's go here. Here is my application. Okay, before going to do that, uh, again, still, we are using this Git repository. You can, it is open to all. In the dev deployment uh, branch, I have pushed all the changes regarding to Docker Compose file or Docker Compose prod file in this branch, and I will create a new branch for the Docker Swarm so that it will be segregated in the multiple branches if you want to copy or if you want to clone or if you want to work on anything. So, okay, it is the Git repo, and in this repo only we are doing all the work. So what I will do currently, I will check like which branch I am in right now. Git branch. Okay, I am a dev deployment. So what I will do, I will do the git checkout. Let's say the dev docker swarm. Git checkout tech doc. Okay, sorry, git branch, not checkout. Git branch dev docker swarm, and then you will do the git checkout tech docker swarm. Okay, let's check git status. Okay, fine. And git branch. Okay, so we are at the dev Docker swarm, and I will update the all the changes which we are going to do in this part. I will update all the things in this branch only. Okay, so we have already installed the Docker. Because of that only we were able to run the Docker file deployment, and we were able to do the Docker Compose deployment. So let's directly go with the Docker Swarm init, init, and okay, okay. I need to provide the advertise address. So for that, let me just pull the host name hyphen I. Okay, it is my IP, and what I will do, Docker Swarm init. I need to use the address. It is the manager address. As I told you, like we have the manager node, master node. You can call it as master or manager, the manager node or worker node. So we need to start with the manager node first. So after it, I will add the IP of my manager node. Okay, let's do the init. Current node 3 is now a manager. Okay, so to add a work, it also provided me the command to add a worker. So if there is any another node in this network, I can just go and run this command on that particular machine or node, and it will be added to this cluster. But here I have only one machine, so I will work with that. So what I will do, I will just do the docker node ls. Okay, so here if you see, I have the ID, that's good. I have the host name, that's fine. I have the status and I have the availability. As I have only one node, so what I need to do is I need to use my manager as a worker too. You can do that too also in the Docker Swarm. So if I see this availability, it is coming as active, and while it is coming as active, it means it can take the work as a worker. Okay, so there's the one thing which is completed. Now let's see what are the changes which we are going to do for the Docker Swarm, and it will help us. So if I see ls-lt, so I will see, okay, I need to do alt. Okay, so I will see this .env file, and also there is one .env.prod. In a standard practice, in a production environment, even in a dev environment too, we do not use the .env file. We do not check in the .env.prod or .env file to our Git or any repository. So how? So this Docker Swarm provide me the functionality to eliminate this thing, because what this env is doing is we are just exporting these all value into the environment and then using in our application. But these all are the values which are which should not be hard coded inside your code. So if I do the cat env.prod, I will see, okay, I have this database URL, this database sync URL, the secret key, algorithm, Celery broker URL. These all are the things which we cannot, or which we should not expose uh, to the repository or to the outer world. It is for the internal services only. So first of all, what we are going to do, we are going to remove this .env and .env prod file from our system. And for the Docker Swarm, what we are going to do, we are going to create the Docker secret. So these all things which are very critical and which should not be exposed inside your application, those will go inside the secrets. So how we are going to create the secret? So for that, let's say echo hyphen n. Okay, so I have already initiated the Docker Swarm. Now what I need to do is I need to create the secret. So docker hyphen n, then let's copy this one, this database URL, and then after it, okay, let me just clear the screen. CLEAR, okay, cat env.prod. Okay, so let's do the echo hyphen n, and then I will copy this string. After doing this, let's do the pipe and the docker secret. Okay, docker secret. Okay. Docker secret create database URL underscore URL and then hyphen. It is the syntax. Like in this way, you can create a secret inside the Docker Swarm. Okay, let me create it and then do the Docker secret ls. So I will find this database URL is created. Okay, so right now, with the help of this Docker Swarm, I was able to create the secret for my one of the key. Let's have just copied all the things there and I will just paste it. So I don't need to write all the things one by one. Okay, so it will create the secrets for all the strings which I have provided in the .env.prod. So let's do the docker secret ls. Where is this docker secret ls? Okay, so I have this algorithm, I have this Celery broker URL, Celery result backend, database sync URL, everything whatever I have just written here in the .env.prod, that is present inside my Docker Swarm. So right now I don't need that .env.prod. So what I will do, I will definitely going to remove that file. So rm.env.prod and also .env file is also there. So I will remove that file too. Okay. So if I do the ls-alt, I will not find any kind of .env file. So my this branch is secure with the data which I do not want to uh, upload into my Git repository. And this particular command which we executed here, actually these commands are triggered with the CI/CD pipeline. So every time when you have some kind of system which you are initiating through your CI/CD pipeline, Jenkins pipeline, or Git actions, these all things executed through from there, and you don't need to write all these things every time one by one or to store it everywhere. Okay, so it is the first part which we did. We have all these secrets. Now let's go and update the Docker Swarm template. So what I will do, I have this compose.prod.yaml, and what I will do, I will CP it because there is not much difference between this compose file and Docker Swarm file. So what I will do, compose.prod.swarm.yaml. Okay, compose.prod.swarm.yaml. Fine. Let's open it. Com oh, I just wrote the wrong compose. Okay, compose. Let me remove the wrong one. RM. Fine. So let's do these VI in the compose prod swarm YAML. Okay, so we have this copy of Docker compose file and we are going to make it for the Docker swarm. So there are few things which we need to remove first because those things are not supported inside the Docker Swarm. And what are those? The first thing which it do not support, that is build. It will not take the Docker file and build the image for you. What it do, it expect a image already created from your end. So in the earlier part, we have already created this fast API ecom backend using the Docker Compose and using the Docker file as well. So we are going to remove the build part here, and we will remove the build part from all the section wherever it is present. So let me just delete it, delete it. Okay, fine. So backend is clear. Redis, we are using already a created image for the worker. Let me delete it, delete it, delete it, delete it. Okay. After the worker, let's go for the migrate. In migrate, we also don't need this, this, and this. Fine. So for the volume, okay, it's the first thing which we cleared from the Docker Compose file to make it in a Docker Swarm way. The second thing which we need is the network. The network which we need to use in this Docker Swarm is overlay in place of bridge. And why it is that? Okay, let me do the overlay. Because when you are working with the Docker Swarm, we need to communicate between the nodes between the multiple machines. So overlay network support this kind of mechanism. The bridge network is used when you have all the thing inside the single node. Well, currently we have all the things inside the single node, but we want to use the overlay. Okay, it is the first part. It is sorry, the second check is also completed. Now let's go for the third one. As we have already created the secrets inside the Docker Swarm, and we don't need any kind of this .env.prod because we have already deleted this file. So what I will do, I will just remove this one. And like earlier in the first section, when we just created the Docker Compose file, we will provide the environment here. Okay, env environment. Okay, fine. It is the environment. And how we are going to take the environment? There are two cases. One for the rest of the services, and the first is DB. Inside the DB, the three things what we need is Postgres user, okay, and Postgres password, 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 and Postgres underscore DB. So when this Postgres take data from the Docker Swarm environment variable, it will take data from the file. It is only for the Postgres. That's it. So what we need to do is we will come here, and what we need to provide, we need to provide it as underscore file, because what it will do, it will go and check for this file and take the data from there. Okay, file, file, and then file. Okay, fine. Let me just update it. Okay, so we have this, and it will take data like this. Okay. So right now, Postgres user, Postgres password, and Postgres DB. So these are the secrets which we created earlier, and it will take data from the files. Actually, when we create the secrets, this Docker Swarm creates some location, some file where it saves this data. And for this Postgres only, we have to use this underscore file with the keywords, and it will take the data from this particular path. Okay. So we just updated the DB part. Now let's come to the backend. Okay, so we have the image. We are going to remove this one. And what we will do, we will just simply provide the command. We will place it like this. Okay, so we have the command. Okay, let me just move it the space. So I have all the things, this database URL, the secret key. There's one more thing, I guess it is missed here. That is, okay, let me go to the end, and database sync URL for the backend. It is required sync, and after this sync, I need to provide the think here. Okay, so I have the database URL, secret key, algorithm, Celery broken, sorry, broker URL, and then Celery result. Everything is there. Fine. You need to understand one more thing. Okay, fine. Gunicon worker. It is the exec. Okay, okay. I don't need this part right now. This command thing. So I will remove this thing because, okay, I guess I didn't provide the access log file. So I will just copy it. Okay, this command is completed. Mm-hmm. Okay, good. Now, another one thing. The Docker Swarm does not support the depends on. And what it do? In place of depends on, it will start all the services and it will wait for all the services to come up. We will provide the logic what you should do when you do the work of like restarting the service. Okay, so what I will do, I will just remove this depends on because it is not required and it will not work inside the Docker Swarm. And there is one more thing which we need to do is in place of restart, we need to provide the deploy condition here. Okay, deploy, and inside the deploy, I need to use the restart policy. Okay, restart underscore policy, restart policy, fine, and then condition on failure. Okay, so it is the condition in which it will work. So we just used the same thing and we created the one service for the DB, one service for the backend. Let's go for the Redis. Image is provided, port is provided, volume, networking, app network, that is fine. We need to remove the restart. Okay, I will remove the restart and I will add the deploy here. Okay, on failure. Fine, it is done. Let's go for the worker again. It will take the image, and I guess we need the same thing which we have provided for the backend. Let me just copy this one. Okay, and in place of Gunicon, we will use the Celery command for the worker. Okay, so here I am, and I will do this, and I'll copy this complete command, the Celery one, and it will go to the end. Okay, let me remove it like this only. Mm. It is completed. Let me remove the Celery command, which externally we wrote like this. Also, we do not need the env file, then we will remove it. This env file. Again, we do not need the depends on, so we will clear this one too. Okay, let me delete this one. Okay, fine. So right now I have this volume, I have this app. Let me just use the deploy on failure. So this particular deploy keyword, you can understand that this Docker Swarm will watch if any service got crashed or not running. It will do the restart. Whenever it will fail, it will do the restart. Restart either in the same node, and if that node is not healthy, it will try to run it on the different node. Okay, so let's come to the migrate part. Okay, so I have this env file. I will remove this one. And again, I need to use some command, and that command will be okay. Let me do the exec here too. Exec alembic upgrade head. Fine. It will do all the work. Let me just remove it. Fine. Depends on will not work here. So I will remove this one. And for the restart, I do not want it to run every time because it is the migration part. So in place of condition on failure, I will do the none. None. Okay. So it is this, this. So I have provided these things, but there is a one more thing which we need to provide, and that is we need to call these secrets uh, again. Okay. So let me add that particular block. Okay. So these are the secrets. So there are two things which we need to understand. First of all, we are defining the secrets here, and there's a one more place where we need to define. So let me define both the things, then I will explain like why we have to define these things two times. So I have this database URL. I need to provide the database sync URL as well. So I will just copy it. Database sync URL, secret key, algorithm, Celery broker URL, Gunicon worker. Okay, Gunicon workers. Let me just copy paste it inside the. It is not called here. Let me use it here. Secrets. Database URL. I don't need the database. Okay, sync URL is also there. Secret key. I don't need the Gunicon. I will remove this one. Gunicon is not required. So I will remove the Gunicon from here as well. Okay. So Gunicon is also updated, and also we need to define one more secret here. Okay. So what this particular secrets are doing and what this secrets are doing, the first thing which is at the level of all the services, this secret is providing the Docker Swarm information that, hey, I have already these variable exist inside my secrets externally. So take the data from there. Okay. It defined the first thing it is. The second thing, this secrets, the list we have provided here, it is providing that, hey, these are the env variables which we need to use inside the container. And it will be like after creating the container, it will set these values which we are exporting. But before creating the containers, also we need these variables, these values. So these secrets are for them. There are few things which I can see I didn't update and have the indentation issue. So it should be like this. Okay, this. It should be indented with the syntax. Okay, fine. It is the first thing, and also the secret should be like this, and this. Okay, so I have these all the things. Okay, let me just do it in a same indentation, so we will not get any issue further. Fine. So backend is fixed. There is no issue in the service DB. Backend is fixed. Redis, that is also fine. Okay, need to do the same. Oh, there is one issue here. Okay, so it is also fixed. That is one migrate. See, I did some mistake here as well. I need to provide $2 sign. Okay, so for now, my grade is also fixed. Secret is also fine. Volume is also fine. Compose, sorry, swarm file. Okay, I guess I didn't provided the secrets like this in my DB, so it is not mounted there. I need to mount these secrets in my DB as well. So what I will do, I will come here and do the secrets. And which secrets I need? First of all, this Postgres user, then this Postgres password, and then the Postgres DB. Okay, let me just update password and then DB. Okay, So here it is, and let me remove this deployment Docker stack rm my fast API. Where is my fast API? Let me just clear all. Okay, so I have just updated this. Fine. It should take all the things. Oh, I forgot to check the DB as sorry, migrate as well. This migrate and fast API DB was not running. Okay, so let me just do the Docker deploy. I hope this time DB will be created so this migrate will work. Earlier there was some issue. So backend is created, network is created, migrate is also creating, DB is creating at the last. Okay, fine. Let's just check all these services. Docker PS running. Only migrate is failed. Task non-zero exit. So we need to work on this migrate as well. Everything else is running. Let me do the Docker stack PS. Okay, Docker stack PS. Where is this? My fast API. Okay, shutting down for this backend. Docker logs. Sorry, Docker service logs, and this my fast API -f. Okay, okay, run secrets database sync URL. Oh, did I missed it again? Let me just check it. In the migrate. Where is the migrate? Okay, I'm using the database URL, but I didn't mount it. Again, I missed it. Sorry, it's my bad. I need to take care of these all things. Okay, so I have this database URL right now, and it will do the work. Database sync URL. Inside the database URL, I should use the database URL only. Do not need synchronized URL. Fine, that will work too. Okay, let me just remove the previous deployment. Docker, okay, Docker stack, RM, Docker stack, RM, my fast API. Okay, I have just updated the migrate. Let's see whether it will work or not. Let's do one more thing to make it more robust. So in place of this command, what I will do, I will try to wait for the Postgres to be in a ready state. Then I will do the Alembic upgrade head. So how will I going to do this? For now, what I will do until PG is ready -h -h. I guess I use the same command above also. So I will just copy it. Redis db. Okay, cmd shell PG is ready -u Postgres. Until PG is ready -u -h Postgres and colon do. I will make the loop here, and what I will do, echo waiting waiting for the waiting for DB. Okay, that will do the work. Then sleep of 3 seconds. Okay, let me just update this semicolon here, then sleep, and then done. done, and this ampersand ampersand, and then do the export. Again, I need this Postgres user and password from the environment variable. So what I will do like this, and same goes here. So what I will do, where is this Postgres user, Postgres password? Also copy it, and I will update the same inside the migrate Postgres user, Postgres password, and okay, this. Let's do the cat here as well. Same goes here, but inside this H. Okay. DB, fine. Uh, Password is not required. Okay, so what I did is I'm just checking this PG is ready from where I'm using this hyphen H. This hyphen H providing the host. This host is this host have the service DB, this service DB, and this service DB have this user with the database user. Okay, it is the database user. Fine. So what it will do, it will wait for this PG ready, and then it will go and start do the other processes which is required inside the command, or which this migrate should do. Let's update the Docker file. Let's update the Docker file image so that we don't have to worry about these things like what are working or what are not. So already I have this ls, and what we will do, vi dockerfile.prod. Okay. Okay, so here is our Docker file of prod, and we need to update the Postgres client here. So the first thing is, if we update the Postgres client inside our builder, so it will not copy that Postgres client. It will have all the essential tools, but that Postgres client is completely different. It is our requirement. It is not a builder tool. So for that, we need this builder tool inside our that image, which will be used by the application. So what I will do after this, I will just paste this one, and inside this apt get update and install, I am just using the Postgres client, Postgres SQL client to get installed, and other all the builder things which are coming from the builder section. Okay, so here it is, and what I will do, I will just do the wq, save it, and then I will just recreate the base image which we are using inside our uh, swarm YAML. Okay, so we have this one, so let me just do the build. Okay, what it will do, we will wait for 2 to 3 minutes. Okay, I will skip it. Okay, so we have this updated image right now. Okay, nothing is there. Then we can start it again. Deploy. Okay, it is just completed, I guess. Yes, it is completed. Okay, let's check for these services again. Docker stack, ps, then stack name. Again shutdown. Why? Mm, My fast API, okay. It is not shut down. It is in the create table. Accepting connection, DB5432, no response. Fine, fine. Everything is fine. We just check it again. Shut down. Oh, I guess it is completed. Fine, fine. Then it's fine. Okay, so let me just check all these services are running or not. Docker PS. So we have things created in just 40 or 30 seconds. We have the service, backend, DB, worker, and Redis. Okay, so these all things are working. So let's check whether this particular application is working actually or not. So for that, where is my Postman? Here it is. And just check that whether this get service working or not. Okay, this get is working. It created a completely new database and it didn't have any kind of data. So let's create one category in the sports. Let's say it is for the clothes. Okay, it is a category of clothes. Create one category. It created one, and let's run the send command. Okay, it created one category, and our application is running just fine as we expected. So finally, after like clearing all those errors, we were able to run the Docker Swarm to deploy our application with like very easy way. I know there were so many things which we need to consider, like what are the services which we are using, how our image should be, but it will make us ready for the next step. Each step, it is making us ready for the next step. Okay, so we should be we should be like a warrior so that we can understand all the things. Okay, so we are good with the part of test. Now it's time to scale our service. Okay, so let's come back here. Okay, now what we will do, actually, Redis is the one which is very small as compared to any other container here right now. So what I will do, I will just scale it to show you how it should do. Docker service scale. Okay, let me just clear it. Clear. Let me just Docker service scale. Docker service scale. My fast API. My fast API underscore Redis equals to 3. Let's see what it will do. Okay, so it is right now trying to create 3 containers for it. Okay, so let's see. 3 by 3 is starting, verifying 4 tasks are stable. Okay, okay, everything is good. Let's check Docker PS. There should be multiple containers for it. Okay, I have 3 containers, Redis 1, Redis 2, Redis 3, in which the first one was from the earlier and these two from here. So as I told you, like we have to do it manually in the Docker Swarm, but if you have any kind of monitoring tool, then you can automate this task too. There is not required that you have to do it manually. And in the next part, we are going to integrate the Nginx as well. So after integrating the Nginx, what you will see here, in place of IP, you will find a perfect DNS. The DNS, domain name system, or a particular site name, whatever you see at the Google Chrome when you are trying to access some kind of website. So we are going to integrate that Nginx inside this application, and also we are apply that change into our Docker Swarm file. So in this way, everything will be deployed in just one go. So that's it for this lecture, and I hope I was able to teach you regarding the concepts, and there were mistakes. I know uh, these all the things are too heavy to like grab all the things at once, and I try to like be more dynamic at the time when I'm teaching. So thanks for watching it, and if you like it, then please share, subscribe, and rewatch it if you want to learn again. And thank you, and keep watching.